Introduction to logarithms. Logarithms allow us to rewrite an exponential equation so that the exponent is isolated. Specifically, if you have a is equal to b to the power of c, then this exponent c is the logarithm with base b of a, and it is written as log the base b of this number a is equal to c. And how do you read this? Log base b of a is equal to c. We have to write this b as the subscript of log, and a is the given number, that's the main thing here, and the exponent c is your answer. Okay, whenever an exponential equation is given to us, we can rewrite, we can change it into logarithmic form. Alright, so let us look at this. When you are asked to convert a mathematical statement or a mathematical equation, in this case, from exponential form to logarithmic form. So a is equal to b to the power of c. In this, b is the base, right? B is base. That base b comes down here. When you change it to logarithmic form, log base b of that number a is the number a, is equal to c, which is the exponent here. Exponent comes over there. Okay. So it's very simple. If you want to convert any equation from exponential form to logarithmic form, just write down log of that number. Here a goes on the straight line, but b, the base, goes down, and c exponent is remaining on the right hand side. In fact, that exponent becomes your answer. So the purpose of this logarithms is that only. If you want to write a big number, for example, I have 10,000 here. 10,000, you know that you can write it in exponential form as 10 to the power of 4, because 10 is multiplied 4 times to give you this 10,000s. Now, this from exponential form, this 10,000, you change into exponential form. Now, what is its logarithmic form? So I'll write log to base 10 of 10,000. This 10,000 is equal to, what is my exponent? That is 4. So 10 to the power of 4 is equal to 10,000. That's how. That is the whole purpose of this logarithms. Rewriting a given big number under a particular base and change it into this small number. Answer 4 is your answer there. Same 10,000. Suppose if I want to write it with a base 100, you know that 10,000, 4 zeros are there. So it is 100 times 100. So 100 square. Written in the logarithmic form as log the base 100 of 10,000. 10,000 is equal to, what is the answer? It is nothing but 2, because 100 square is equal to 10,000. Similarly, one more example here. 2 to the power of x is equal to 75. This 2 to the power of x equal to 75 is written as log of base 2 of 75 is equal to x. So This 75 goes over there, base 2 is down here, and exponent is your answer. Okay. Now let us see two more examples. You have here 2 to the power of x, the first one. 2 to the power of x in logarithmic form, it can be written as log base 2, right? Because the base is real, right? Log, okay, log base 2 of 16 is equal to 4. And clearly we see 2 to the power of 4 equal to 16 here, right? Very simple. 2 to the power of 4 is equal to 16. So log base 2 of 16 is equal to 4. That is the logarithmic form of 2 to the power of 4 equal to 16. Similarly, what do you have for this? 5 to the power of 4 is equal to 625. How do you change this into logarithmic form? Same thing again. I'll write down log first, the base 5. My number is 625 is equal to 4, the exponent. Now, how do you convert a mathematical statement from logarithmic form to exponential form? So, given logarithmic form is log base b of a is a c written as b to the power of c is equal to a. Alright, this base b goes over here. B to the power of c is equal to a. That's how we can change from logarithmic form to exponential form. To the power of this exponent, that is b to the power of c, is equal to that remaining number a. So a is equal to b to the power of c. Either way it is the same. Writing it in exponential form, a is written in exponential form there. Okay, let us see few examples. Log base 4 of 16 is equal to 2. So what is its exponential form? It's going to be 4 is the base, so 4 square is equal to 16. 4 square is equal to 16, or same thing, that 16 is equal to, this 16 is equal to 4 to the second power, or 4 squared, right? The same log of this with a base 4, instead of taking base 4, I'll take log base 2 of 16 is equal to 4, because now change into exponential form. 2 to the power of 4 is equal to 16. When 2 is multiplied 4 times, your result is 16. So same number 16 with the base 4, it becomes 2 is the result, and the number log of 16 with this base 2, the result is going to be 4. Okay, so you have to practice some problems of this type. Now, even if you come across some exponents like y is equal to 2 to the power of x, it is given in exponential form. How do you change it into log? Log, the base was 2 of this y is equal to my exponent x, right? This is how you can convert whatever way they give. Suppose sometimes, let us say you have m to the power of n is equal to p. So what is the logarithmic form of this exponent? I'll write log the base, I identified base as m, of that number p is equal to exponent n. Please don't forget to write m as the subscript of this logarithm. That's how we have to put it down as the base. That is the right syntax, right way of writing this log of that base. Okay, please try few examples. Thank you.